Welcome to Premath. In this video tutorial, we are going to show that this infinite series 1 plus 2 plus 3 all the way to positive infinity equals to negative 1 over 12. So once again, this left hand side part is called infinite series. And this infinite series could also be represented in a sigma notation like I just put it over here. So these are exactly same things. To get a full understanding of this topic, please watch this video to the very end for additional practice problem. So let's get started with our proof. And here's the very first step. What I'm going to do is I am going to call this left hand side part of this equation, I'm going to call it S. S stands for series. So S equal to 1 plus 2 plus 3. It goes all the way. Dot dot means it goes to positive infinity. Alright. And moreover, we are going to consider two more infinite series. S1 is going to be equal to 1 minus 1 plus 1. These are ones with alternating signs. And series S2 is almost same look like S series. Only thing is it has also alternating signs. Well, you might be wondering, why do we need these series S1 and S2? We need these two series that is going to help us in proving this given problem. And here in our very first step, let's consider this infinite series S1. I just put it down over here. S1 equal to 1 minus 1 plus 1 minus 1, and it goes all the way to positive infinity. Here I want to write down something. I'm going to say 1 minus S1 is going to be how much? So this is what we will be doing. So this is 1 minus S1 equals to, I can write 1 minus S1 is this whole thing. I'm going to just go ahead and 1 minus 1 plus 1 minus 1 plus 1 and minus 1 plus all the way. I just put it down over here. So on the left hand side still we have a 1 minus S1, and on the right hand side, if I open up this parenthesis, this simply is going to become 1. When you open up this, it switches all the signs. It's going to become 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1, and goes all the way, isn't it? And if you look at this right hand side, this part, if you look at this infinite series, this is same as S1, isn't it? So this is, so we got simply, this tells us that 1 minus S1 equal to this one. Let's go ahead and move this S1 on the other side. So we're going to have 1 equal to S1, and this negative S1 become positive S1. So that means we got simply 1 equal to 2S1. And now I'm going to divide, I'm going to isolate S1. I'm going to divide both sides by 2. So simply that means, see, this 2 and 2 cancels out. So we got S1 equals to 1 over 2. And in next step number 2, let us consider this next series is S2. I just wrote it down. S2 equals to 1 minus 2 plus 3 minus 4 plus 5. It goes all the way to positive infinity. And now I am going to add S2 to itself. What that means is I'm going to write down S2, and then I'm going to add S2 to itself equals to, let's write it down over here. I am going to write down, first of all, S2 first, 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus goes on and on. And then I'm going to add another S2, and I'm going to add S2 right up here. I am going to add over here, I'm going to say 1, and then I'm going to say minus 2 plus 3 minus 4 plus 5, and then it goes all the way. Let's add this thing up. I'm going to add this one up. Okay, once I add these thing up, as you can see, this over here, this 1 stays there, isn't it? And then negative 2 plus 1 is going to become negative 1. And this, see right now, let me go ahead and match them up. You see this one over here, this is going to give us negative 1. This, if you add them up, it's going to give you positive 1. That's going to give you negative 1, positive 1, negative 1, and goes all the way. So I can write as, over here, we have to be very careful. So 1 minus 1 plus 1 minus 1 plus 1, and this infinite series goes on. And on the left hand side, we got S2 plus S2. If you add them up, that is going to become 2S2. All right, let's move on furthermore. Okay, over here, I'm going to just write over here. Now, over here, as you can see, this right hand side, 1 minus 1 plus 1, isn't it? This is same as S1. So this is, the right hand side is same as S1, and on the left hand side we got 2S2. All right, now I'm going to isolate S2 by just dividing. I'm going to divide both sides by 2. So that gives me essentially S2 turns out to be 1 over 2 S1. But we know that S1 has a value, as you can see right up here. S1 is 1 over 2. I'm going to just plug it on over here. So S2 equals to 1 over 2 times S1 is 1 over 2. I'm going to just put it down over here, as you can see. So that means we got S2 equals to 1 over 4. And here in our final step, which is step number 3, we are going to subtract the series S2 from S. And here I put down S series, this one, this is S1, this is S2. So let's write it down. S minus S2 equals to, let's write down S series, by the way. So this is S series is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 goes on and on. And then I said minus, and then S2 is 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus goes on and on. All right, so let's simplify now. So this is simply is going to become S minus S2 equals to, on the top we still have 1 plus 2 plus 3 plus 4 plus 5 plus 6, on and on. And then here, let's open up this parentheses. When you have a negative sign, it's going to switch the sign. So this is going to become negative 1 plus 2 minus 3 plus 4 minus 5 plus 6 minus all the way. Now let's look at this one over here. Negative 1 and positive 1, they cancel out. Negative 3 and positive 3, they are gone. Positive 5, negative 5 are gone. So we ended up on the right hand side. 2 plus 2 is going to make 4. 4 plus 4 is going to make 8. Plus 6 plus 6 is 12. Plus goes all the way. And on the left hand side, we got S minus S2. And now over here, since you can see 4 is in common, I can factor out 4 from here, from this series. I can write 1 plus 2 plus 3 plus 4 all the way. And as you can see, this whole thing is our S, isn't it? That is our S. So I can write this one as, on the left hand side is S minus S2 equal to, this simply become 4 times S. Now let's go ahead and move this S on the right hand side. So we are left with negative S2 equal to 4S. And when you move this S on this side, become negative S. So that means negative S2 equal to 3S. And now I'm going to isolate S by dividing 3 on both sides. So that means we're going to have S, this S3 cancels out. So S turns out to be negative 1 over 3 S2. But we know that S2 is 1 over 4. So wherever you see S2, I'm going to replace that one. So simply I got S equal to negative 1 over 3 times, that is going to be 1 over 4. Let's simplify that one. So that is going to give us S equal to negative 1 over 12. And we know that S is 1 plus 2 plus 3 plus all the way to positive infinity. And thus we have proven that this infinite series of the counting numbers equal to negative 1 over 12. And here is your assignment. Can you do it on your own? You can take your time. Luckily, I have already uploaded this video as well. Please go ahead and check it out and see the correct answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.